In statistics, we'll be talking about variables. Variables in statistics usually get capital letters, usually X or Y, and they represent the characteristic of interest. That is, what are we studying about this population? Now, these variables can take on two different forms. The first is categorical. The second is numerical. The categorical variables, they take on values that are categories or words. Numerical values or variables are, as it sounds, they take on values that are numbers. So, for example, a class is asked, who is the mobile carrier of your phone? Each individual is asked this. Okay, so in words, what is the variable? Well, it's going to change depending on the student. So this random variable, we'll call it X, is going to be the name of the mobile carrier. And since the random variable will take on values that are names, it is categorical. Examples of data that you could include, well, my carrier is T-Mobile. That could be one. Someone might have Sprint. Or someone might have TracFone, etc., etc., etc. So we could go back and revisit these examples that we had in example one. In example one, the first one asked about, had you ever flown on an airplane? And the types of responses that came to this were either yes or no. So these values can be categorized, the yes category or the no category. So this was a categorical variable. Let's see, the second one asked us about the horse heights. Those values were in inches and they were numbers. So this is a numerical variable. And the last one asked us about the make of the vehicle. And we said that that could be like Saturn or Ford or Audi or anything like this. Again, we could categorize the cars by their make. This is a categorical variable. Okay. So variables can be categorical or they can be numerical. And that leads us to talking about what are the types of data. While the values of the variable can be categorized as numerical or categorical, the actual values of the data can also be categorized, and they can be categorized as qualitative or quantitative. The qualitative data, you see the word quality in it, these data values take on non-numerical values. The data can be placed into distinct categories according to a certain characteristic. Okay? On the other hand, we could also have quantitative. That is, you could look for a quantity, and it consists of numbers that can be counted or ranked. Now, once you start counting or ranking things, there are two different types of variables that you will look at. The quantitative variables can be broken into two categories. One is discrete. This is where the values can be counted, say 0, 1, 2, 3, etc., etc. So they only take on these very specific counting values. But not all data is that way. Some of it is continuous. They can have infinitely many possible values. That is, the variable can assume all values in between 2 points. So say, for example, you can get decimal approximations. Like the height of the horses, we said could be 36 or 36.1 or 36.11 or 36.001. There are all of these values that it can, that measurements can assume. And that's going to be the crux here. If the data can be measured, you will think of it as continuous. That is, time is continuous, money was continuous, weight is continuous, etc. Anything that can be measured is a continuous, a quantitative variable of the continuous type. Okay, so let's try and describe the different types of data as qualitative or quantitative. And if it is quantitative, we're going to state whether it's continuous or discrete. So in part A, we can look at the number of pairs of shoes that a person owns. Okay, so when we talk about the number of pairs of shoes, okay, you have to have both both shoes to have the pair. You're only going to have either 0, 1, 2, etc. However many different pairs that you own. This is a variable that's taking on numbers. It is quantitative. And those numbers are only counting numbers, so it is quantitative and it is discrete. Again, we can look at the type of car a person drives. This will take on different values like Ford or Audi or Chevy or whatever, Toyota. These are categorized. Okay, so this is qualitative data. I could ask where someone goes on vacation and they could say to the Bahamas or to Wisconsin, or currently we can say we're staying home, the new staycation. These are again qualitative descriptions. On the other hand, you could look at the distance it is from home to the nearest grocery store. That will be a number, so this is quantitative. Distance can be measured, so this is quantitative and continuous. When you go to the movies have, well, you don't even have to go to the movies, but movies get assigned ratings, PG, PG-13, G, etc., etc., etc. These are qualitative descriptions about the movies. Political party preferences, again, these are qualitative descriptions about people's political preferences. We could look at the weights of sumo wrestlers. Weights is something that can be measured. They are numerical measurements, so this is quantitative. It is a measurement, so it is continuous. We could ask about the temperature of infants in a hospital nursery. Temperature is something that can be measured. It is measured numerically, so again, this one is also quantitative and continuous. Now, there's other ways to categorize data. There are different levels of measurement, so sometimes you'll see these classifications as well. Okay, the first one is the nominal classification. It deals with names or labels or categories only. Okay, we cannot arrange the data by ordering. So, for example, genres of movies, comedy, sci-fi, adventure, family. There is no ranking to this. It is just a label. Again, the political party affiliations, Republican, Democrat, Independent, Green, etc. There's no ranking to this. It is just a pure label. Now, on the other hand, there's something called ordinal. And again, these are labels, but data can be arranged in some order. But we're really not going to use any of these orderings or these in any sort of calculations. So, for example, ratings could be good, better, and best. There is some order to this, but we're never going to say take best and subtract better and come up with good. That would make no sense. Or our Netflix ratings of the stars, 1 to 5 stars, right? 1 star being the lowest, 5 stars being best. But again, we would never say, like, I'm going to take 5 stars and subtract 4 stars and come up with 1 star. That's the ordinal level. We can start to do some calculations at the interval level. Okay. Here the data can be arranged in order and it can be used in some calculations. But there is really no natural zero starting point, and I'll explain this. Differences between the measurements, so this is talking about subtractions, these actually will have a meaning, but a ratio, this is the division of measurements, does not. So let's think about years, okay? Time does not begin at the year 0, but we label our years as numbers. Okay? So time does not start at the year 0, so the label of 0 is arbitrary, therefore this is interval type of data. Okay? Now, differences do make some, they do make sense here, right? Because we could say that between 1950 and 2000, there was 50 years. Okay, so 50 years does have a meaning. But say, for example, something like year 1000, it is not half as long as the year 2000. Because remember, we just started at an arbitrary 0 point, so it doesn't make any sense. We wouldn't say year 1000 is half as long as year 2000. It doesn't make any sense. Let's see, another example of this would be in Fahrenheit. There is a 0 in the Fahrenheit, but that doesn't represent no heat. And we don't say that 50 degrees Fahrenheit is twice as hot as 25 degrees. So that ratio doesn't make any sense. But we do know that 20 degrees is more than 0 degrees. So the differences make some sense, but the ratio does not. And lastly, the category where the ratio does make sense is called the ratio. Again, data can be arranged in order. It's used in calculation. This time there is a natural 0 starting point, and this is the crux about being able to use ratios here. The differences and the ratios between the data is meaningful. So, say for example in weights, a weight of 0 does represent no weight. We can talk about lengths and minutes of movies, and it makes sense to say that 60 minutes, is not twice as long. 60 minutes is half as long as 120 minutes. We can talk about distances. A 0 distance makes sense. We can talk about money. 0 money makes sense. That is when you have no money. And we can say things like $200 is twice as much as $100. So those are all the various ways that we can talk about variables and their measurement levels.